But
This meeting is being recorded.
it's a New York season, so not everybody is able to join. But hopefully, we can kick off this MOC and TVM language model focused session. So today, I think we are going to have two topics, right? One topic is we are going to give everybody update of our serving status. And a lot of our current activities recently have been on pushing continuous batching support. And then with the goal of trying to effectively moving most of the API towards more like OpenAI compatible layer. So that is something that definitely we see a lot of community need, and it is something that we would like to, consolidate and moving towards that direction. So I think that's the first part. And the second part, I think Yashin is here and he should be able to give us the update on the flashing for interrogation, and then we can open the floor for, open discussions. How does that sound? Yeah. Okay. Sounds good. As a first step, maybe what we can do is we can, have Rehan and Song is also here to tell me a bit about our current progress of the continuous batching support. Rehan, please take it away.
Sounds good. Hi, and give me a minute to share my screen.
Do you have a demo that you can share with everybody? No?
I didn't prepare a demo, but I prepared a few slides. Basically,
Sounds good.
Oh, if you have a link to these slides, by the way, those would be good for the notes.
sorry.
If you have a link to these slides, that would be good for our
sounds good.
notes
I
for our
can.
note keeping.
Let me check.
You can send it to me afterwards. It doesn't have to be now.
Oh, okay, cool.
Thank you.
Looks like I quit it. Yep, I think now everybody can see my screen. And right now, today I'm going to share a bit of our latest updates on the serving branch of MOC, which we have been heavily pushing over actually the past a couple of months. And right now we do have a branch separately, besides the main branch that has the serving support set it up. And right now, our vision is that we want to build a serving framework and a serving platform that is able to support first like continuous batching, definitely for sure. Oh, I typed two batching here, ignore it. And definitely we want to bring the serving framework to everybody so that people can use it with some well adopted API like the OpenAI API. So we are building towards the full OpenAI API compatibility. And for the third point, we have built the MLC serve with the tensor parallelism, which is enabled by the distributed runtime in TVM that our folks from community built a couple of a while ago called Disco. And the Disco runtime is integrated into the MLC serve. And we use the underlying page KV cache to support efficient KV value management and also backing the attention computation. And this is of course some well adopted way by most of the serving frameworks so far. And we use the efficient hand optimized attention computation kernels. And I will I will debrief this a little bit later. And we are going to build the MLC serve for multi-platforms, including the NVIDIA GPUs, AMD GPUs, and also Apple GPUs. And the current expectation is that we want to roll out the first version of MLC serve, which basically definitely merge the serving branch into the main branch by the end of this month or this year. And moving on, just expanding a little bit for the OpenAI API compatibility. Right now, we already have the entry point of the OpenAI API v1 chat completions in this file, and right now we have not yet support every field or every arguments in the OpenAI API, but the goal is definitely to fulfill all of them, and in the coming weeks, including the JSON output format that enforces the output of the model to be strict with the JSON schema, and also support for function calls and some of other fields like the log probability and so on and so forth. Next is the tensor parallelism, and just as what I have enabled before, this tensor parallelism is achieved by the distributed runtime disco, and you can actually check out this pull request. I think it was merged a couple of months ago, and actually in our main branch, the current tensor parallelism support for the single sequence MLC chat is also backed by the distributed runtime. And right now, for our preliminary evaluation, the tensor parallelism can deliver with very strong performance. And the next is KB cache, and adopted from VRM project. And one particular thing we would like to highlight here is that our page KB cache supports the common prefix caching, which means, say, if I have a very long, it can be a system prompt or some documentation, we can first send it to the KB cache to compute the KB value and store the values in the KB cache. And for the incoming rounds, if I want to have the context of the previously fed documents or system prompt, we will no longer need to do the same computation for another time, and instead we can directly reuse the previously cached common prefix in the page KB cache for different say follow-up request. And yes, and the next is the efficiency and the attention computation. For the platform CUDA, right now we use the Flash Infer, which is a very efficient Flash attention implementation on CUDA, and you are more than welcome to check out this repository to see more details in the Flash Infer. And I think, as TQ mentioned, Yashin will also talk about the Flash Infer integration for our single sequence MLC chat later on. And right now, the Flash Infer support is only for CUDA. So what we are going to do, basically, in order to broaden the support for multi-platform, we're going to bring some of the techniques used in Flash Infer or Flash Attention to other platforms with the handwritten code in the form of the compiler's intermediate representation in TVM. And right now we are keeping conducting benchmarks and evaluations and for our serving projects. And right now, I think for some of the preliminary results, we are pretty good. And definitely, since we are having more things to do, we want to finalize some of the losing end, and also keep evaluating the things. So we will have a blog about the performance and these serving branch when we roll out the first version. And here are some other ongoing items. And for example, what I can think about is definitely the model support. Right now, we only focus on Llama for the first version, and definitely we will extend this model support to more models Like for example, like Mistral is definitely one of them, and also other models as well. And yeah, I think besides that, I'm not sure if I missed any item here. And likely one thing is that we are going to right now these models are defined in the old or in the current model definition flow in MOCLM. And I believe one topic that has been introduced in the development meeting before is that folks from community have built a new model definition flow and compilation flow called Slim, and we will switch over the MOC serve models to the new compilation flow and model definition flow after we finalize the serve for the first version. And this is one also the ongoing item. And likely that's it for my introduction today. And I'm not sure if I missed any points, so if I did, please point it out. And I think I can, yeah, that's it for me today. Thank you. Let me share the link and send it to the Zoom.
Thanks, Ruhang, and we appreciate the updates.
Yes, and maybe we can leave QA to the end, so we can let Yaxing to come in and talk about Flash Infra as well.
Sure.
By the way, Rehan mentioned that, so I forgot to mention another point. So actually, folks like Charlie, who is here, and others are working very hard on rolling out our second generation of compilation pipeline. So the previous generation, I know that it's a bit hard to add model definitions and so on, and the quantization format. So right now we are rolling out a second compilation pipeline called Slim. And that is we are looking forward to get that landed in the community, I think, in the incoming weeks. So the goal is the MLC server will also use Slim pipeline, and so that we are getting closer to our goal of getting everybody to be able to define the model more easily, and also ship to more platforms more easily. Okay, Yaxin, please take it away. Yeah.
Oh, yes. So thanks, Tianjun and Rehan. And I'm going to share my screen. Yes, in the past weeks, I working on the Flash info integration into our MLCLM to our code base. And I will introduce two parts today. One part is about how to integrate the Flash info. And of course, you can integrate your customized library into our MLCM via the source module. And the other part is about the performance of the Flash info end-to-end in our MLCM. And the Flash info is, as we have mentioned, it is a CUDA-based, like the Flash attention library, and it's focused more on the long context scenarios and also the batching serving scenario. So, and it also supports the TVM wrapper here with the TVM like interface. So with the help of the things like the type function, the global type function, we can easily to integrate into our MLCM. So in our MLCM, we directly use the source module here, and the source module is a structure to enable us to introduce the source code into our module, the Steam pipeline. And here we directly inherit the source module, and then during the constructor, we can help you to compile the library into an object file, and you can also add some your customized compilation options, or also include some necessary headers here, like the DL pack or the MLC call. And finally, we will help you to compile a object file, and you can link it into our pipeline. And also you have to specify what function you want to expose. Like here we only expose the single step, the single batch prefill with the KV cache flash info function, and also the single batch that decode with the QVCatch function. And you input the QKV, and also if it is a coarse attention and the layout here, and if you want to use the auto embedding or even some other arguments. And also here is the arguments of the decode part. And then you can expose it by a function or a method of this source module. And here you can directly use the get external function. And our source module will help you to find the symbol. Like you select that you want to call this function, and we will help you to convert the function here into the relax function. So you don't need to care about what's happening on here. So you directly call the function in our source module. And finally, in the Llama model, like the model definition, you directly construct a flash infer, and you can call it by this method you expose, and finally you can directly use that like the other built-in kernels or built-in operators. So it is quite convenient if you have other customized libraries. You can directly pass them into pass their source code into our source module and tell us how to compile. And finally, we will help you compile, and you can directly link to here. And in the future, we will simplify these pattern more to make the compilation more easier, and maybe do some optimization over the compilation here. Yeah, and this is how we integrate the flash infer into our MLC Steam pipeline. It's not very hard, because it's only about 200 lines of code, and some of them are the docstring, and some are the model definition and the object definition. Yeah, and with the help of the flash info here, we did some simple experiments over that. We test the Llama 2 with the 70B with the int4 quantization on the single 100 card. And you'll see that within the old pipeline with the flash info, when we increase the prompt from the maybe 500 to 1,000, 2,000, even 4,000, then the decode speed will slow down very much, like from the 22 to 21 and the 18. And even in 4K, it is about 14 tokens per second when it is in decoding. But with the flash info, it has some optimization with the long context here. So you'll see that the speed of the decoding is almost the same with minor details. So when it comes to the smaller model, like the 7B, that you will see that the same pattern when the prompts increase from 500 to even 4K and even larger, the flash attention fail to handle such long context. And with the help of the flash info, we can still keep almost the same level of the performance in the decoding. And the prefill here is kind of slow compared to the flash attention, and we think we will take a look to check what happened here. Maybe this is the end-to-end, so maybe there is something wrong with the part of other than the flash info here. And also need to be mentioned that the 4K here may not be very accurate, because I forgot to change the max sequence length here from 2K to 8K. So we will retest the result, but the pattern should be the same, that with the help of the flash info, we can handle the much longer context in our generation. Yeah, this is the integration part of the flash info.
Okay, sounds good. Thanks, Yaxin. Okay, I think we can open up for discussions and questions to see if we have thoughts from audience. Yeah.
Hey, I've just got a very quick one. We're looking at trying to deploy like an efficient server, and I'm keeping my eyes on a few different communities. What does the movement of a pipeline like this into production look like? Because I know that we're facing a lot of complexity with having you know, everything from Dockerizing, um, like pass through of GPU availability to Docker to um, Kubernetes so that it can eventually be hit, on the server. And I imagine that that's complicated with a runtime that supports a whole bunch of different um, underlying hardware. So it's not just necessarily CUDA pass through, it's, pass through of whatever hardware runtime. Um, is there a way to abstract away some of those complexities, or do you think that's something we'll need to look at when you know the specifics of your production server?
That's a great question. So I think for common GPUs like AMD and NVIDIA, there should be pass-through solutions already, right? For more as aesthetic GPUs, and maybe there will be a problem. And additionally, likely, depending on whether or not you prefer containerized or versus non-containerized, right? So you should be able to directly install and run it. Uh, that could be different way, yeah. So depending on whether or not you container is a requirement or not, yeah.
Cool, thank you. Also, big fan.
Thank you. Yeah.
Oh, I have a question. I usually bring more question than contribution to these meetings, so this one is no exception. The first question is with batching. For those who have very few GPU, like one or two maybe, what exactly what benefit does it bring? Is it going to cause the completion to finish faster? Is it going to process more at a higher token rate, or is it just the efficiency and throughput as you pump more and more of these completion? If you have such a flow that is gained by you converting over to batching, that's not quite clear to me anyway. Then the second question has to do with the buzzword of the day, Mistral. And there's recently something called mode that has come up, which is like mixture of expert. I'm just wondering if our pipeline is actually capable of handling that type of modeling, and whether it only have impact on batch type of situation, or even when batch size is equal to 1. So that's my two questions. Thanks.
Maybe Rehan, you can take this.
Yeah, sure. So for the first thing, the first question is about the benefit of the batching enabled when only the computation resource is limited to like 1 or 2 GPUs. And in this case, usually the thing is that if the use case is only to just say I am a end user and I only build up my own MOC app and I want to chat with the app, then likely the current MOC chat is sufficient. But if we're going to build a server that faces like requests from different people, then in such cases, batching will bring more throughput to the overall app. This is basically due to the fact that in the transformer-based model, in the decode step of such transformer models, the overhead of a decode step is mainly bounded by the memory. So in this case, if we enlarge the batch size, which means we feed more input prompt into the, say, a serving engine, then the model can run with higher throughput without without enlarging the end-to-end latency too much. And this is one great benefit from the batching support here. And for the second question about the Mixtral, yes, in the past few days, our group, or together with some other collaborators in the community, we are pushing a support of the Mixtral, a mixture of experts into our pipeline. And right now, at this moment, we have some progress on. I think the CUDA pipeline is enabled with if we leverage some kernels from say NVIDIA Catalyst, and it's for such flow, it is enabled. And we're also building the flow that is completely enabled by the machine learning compilation by TVM, completely using the kernels, including the mixture of expert flow involves some new operators that we don't use for say simply llama prefill or llama decode. These operators include the top K and includes the maybe it can include the cum sum depending on how we implement it. And yeah, so we are building these new operators to the flow using the code generated by machine learning compilation. And we do expect to roll it out very soon, I think. Right now we are still pushing some of the performance critical operators, and basically the matrix multiplication pattern in the mixture of experts is different from what we usually handle in the say llama prefill or decoding. This is because say in the mixture of experts model, the MLP layer of each model usually have different copies of, well, not exactly copies, they call it experts. So say in llama model for the MLP layer, I only have one MLP weight. And in terms of the mixture of experts, we will have say eight MLP weight in a row. And in runtime, say when I want to compute the MLP output for a hidden state of a single token, what we will do is that we will first using a gate function or a router. This is usually in the form of a linear layer to compute the logits of this hidden state for each expert. And we will we will use top K. For example, like in the mixture model, they use top 2 to select the 2 experts with the highest score. And after that, we will dispatch the MLP computation of this hidden state to the particular 2 different models. And we then use the weighted sum mechanism to sum up the outputs from different experts. So to support such patterns, the matrix multiplication is a bit different from previously. The matrix multiplication in the, let's say, llama model is just some usual matrix multiplication or GMV. But in this case, we will need to extend it to grouped matrix multiplication. So for this side, we're still having some efforts on it, but we do expect to roll it out soon.
Thank you. That's amazing. Thanks.
Thank you.
Yeah, and we noticed that through the mixture lecture support, we do need to add support for scan and sort. And Bohan had done some preliminary hackings, and Yong is also working on some of the related official support on the Relax pipeline. So hopefully, moving forward, it will be even easier to add in those models. Yeah. Okay. Any other thoughts from folks here?
I have a quick question about. I'm a little curious about the C integration in NN.source module. So I guess, yeah, I guess I'm a little curious how this works. So the idea is you can just write inline C code. Is it going to be turned into a packed function? Is that the idea?
Yes. In the C source part, you have to wrap it with the TVM, like the DLL pack function. Yeah, and then when we link in, we have that symbol. Yeah, we can directly use that symbol in our final module.
Very interesting. Thank you. That's yeah, it's definitely an interesting capability. I wonder if it might have uses outside of Flash and First support. I could see this being great for testing at the very minimum. But probably, I mean, it will probably have a bunch of other applications. It's a great capability to have.
Yes, we should enable more minimum the interface for the Flash info that you can migrate that onto multiple platform, not only the TVM part. Or you can also maybe call the Python directive from some kind of binding here. And that can be the future plan.
Thanks.
Okay. Any more thoughts from folks here? Well, if not, so maybe we can conclude early. We get the folks get back to hacking, and hopefully, you know, we'll. I think there will be a lot of exciting rollouts. So one of the things we start to realize is that, you know, definitely for APIs, we want to start converging towards OpenAI APIs. So a lot of effort recently we'll try to align around that and try to make sure all the APIs start to work towards OpenAI API compatibility. And you know, the universal deployment story is also coming together. This year, we have pushed for several components, including distributed, multi-GPU, batching, and all these features that is why like things are shaking around, right? And this new compilation pipeline, but we are stabilizing right now. So getting all the pieces connected, and we want to aim for feature complete, at least V0 feature complete, so that we'll be able to get you know, more stabilized version, as well as the version that help us to be able to bring in more models easily. So that's, you know, I would expect to have, you know, new events in the new year, and hopefully thanks everybody for joining, and looking forward to see each other actually in a new year as well. So hopefully you have a happy new year and a good holiday, and you know, that's continue hacking. Yeah.
Thank you very much, Tianqi. I want to also make an announcement very quickly. We are still having a community meeting next week, so that will be the last one of the year. A little bit less fanfare, an ordinary community meeting. And another announcement that I made a little website for collecting notes from these meetings.
Yes,
Hopefully, it's more user friendly than our massive and bloated Google Doc. So I encourage you to use that. Thank you for listening, and thank you again, Tianqi, for the encouraging notes on our development this year and what to expect next year.
Sounds great. Yeah. I'll see you folks.
Happy holidays.
Yeah.
Happy New Year. Bye-bye.